Hello, welcome to the setup video. We're going to set up the part with the stock work holding all ready to go exactly how it will be on the machine. First step will be to design your stock. So we're going to create a solid in the design workspace. We're going to click on create, go down to bounding solid, and we're going to create the stock. So this is a very nice feature recently added to Fusion. Before you would have to draw your stock to the model. Now it does it all for you. So the first selection is to select your model. Now it's orientated the model or the stock to the model to use the least amount of material, which is a very nice feature. But for the sake of this job and many jobs really, I want the job square to the machine. So when I'm looking at the positions of the holes on the machine in the program, they're relative to the drawing. So we are going to, on the coordinate system, take it off automatic, go to X and Y, and then you'll select your Z and X, you'll select your Z and your X axis. This has turned out perfect, exactly how we want it, so it's square to the job. Now, the second selection down asks you whether you want a fixed size box, relative size box, fixed size cylinder, relative size cylinder, or tube. So we want a fixed size box. We're going to give it the dimensions of the stock we're using. If you're at quoting stage, you might want to use relative size box, and then just add the material that you want to clean up, 1.5 million a side, maybe a little bit more on the Z-axis for your work holding, etc. But I know the stock I bought 5 inch by 1.5 inch. So I'm going fixed size box. My width I cut at 283. It tells me down the bottom here model dimensions, so the exact size of the model. We got 278, so I've cut that 3mm, 5mm oversize, which is quite a lot really. But then it depends, if you're probing the parts you can go a lot closer than that, but if you're slapping them on the vise you might want a bit more. So my X width is 283mm. My Y, that was my 5 inches, so you can do the maths in the box as well. So 5 times 25.4. That'll calculate that for me. And my height was 1.5 times 25.4. Z position, offset from top, and I want 0.5 mil left on the top to clean up. So that's ready to go. Click OK. Now we've got our stock. If we drop down our component, we can, let's name our model body model. Component 2, let's name that the stock. It's important to set up your tree with your models exactly how you want it before you start manufacturing, because if you make any alterations after, you have to go back in, and sometimes you have to select all the geometry that you selected again because it will lose it. Everything's referenced back to the part by its name, which can be a pain sometimes. So now we've got our stock, we can also, if we go down into our stock, right click on it, and then opacity control, we can make it see-through. So we've turned that down to 10%. Let's go on the top model. So now our stock is see-through. Makes it a little bit easier to work with at the moment. Now we're going to pull in our work holding. So I'm using a Lang vise on a riser. I'm going to open up my data panel, pull in my vise. Let's close that down. And we are going to move it into position. So if I just close out of there, I've got, on my vise, I've made 2 points. So I've got a point which is relative to the seat face of the jaws, and a point that's relative to the seat face of the vise. Both of them in the centre of the vise. This is what I use to position my part centrally to my vise in seconds. So I've pulled my riser in now. If you see the little chain symbol here, that means that the model of this vise is linked back to the original model. So any changes I make here will change my original model, and if I make any changes in my original model, it will change in this model. I don't want that, so I've pulled it into this setup. If I make any alterations for this setup, I don't want that to lead back to any other issues. So I'm going to break the link. So I broke the link. Now this model of this vise is only relative to this setup. Now I'm going to put a point in the center of my stock on the back. Let's hide the vise. So I've created a sketch on the back of this part. I now want to put my part in. So we've got 283 divided by 2. Put my part in, put my point in. And then we've got, what do we have? 127 divided by 2. So now my point is in the center of my stock. Finish the sketch. Well, I created that sketch on the top level, so it's put it in here. I didn't want to do that. I want that sketch to be a part of the stock. So if we move the stock for any reason, that sketch wants to move with the stock. It needs to be a part of it. So if I just drag that and drop that in there, now that sketch is a part of the stock body. So if we move the stock for any reason, the sketch will go with it. That's very important. So what I should have done when I created that sketch is highlight just the stock only, then create the sketch. It would have automatically gone in there. It's very important to keep everything neat and tidy, especially if you're doing a big model, feature-rich model, because it saves a lot of time in the long run. So now we're back on the top level. Let's turn the vise back on. We need to move the vise into the position that it's going to be out on the machine. This is going to help us make sure we don't gouge the vise, cut the vise jaws, etc. So now I want to move. I'm going to select my vise, and then we're going to go point to point, origin point to target point. Now it's in position. That's exactly how it's going to be on the machine. Click OK. I want to align my let's ground to parent where it is now. So if I don't ground to parent, I can still move the vise around. So we've put it into position where we want it. Right click on the vise, ground to parent, ground. Sorry. Ground to parent. We have an error. Component has been moved. Ground to parent will override the move. We don't want to do that. So we're going to update initial position, and then it will ground. It's ground where it is now. So now when we move the jaws, the vise stays still. So now we would like to align the jaws. This is just to make sure everything is perfect. So we've clicked align, clicked on the jaw face that's going to be sitting up against the stock, then we click the stock wall. Simple as that. So now from our design workspace, we are ready to go into our initial setup. So we're going to click on the top left corner and go into manufacture. So our first option is setup. If you look above, you've got milling or turning and a few others, but we're only interested in these at the moment. So we're going to milling, click on setup. We'll try and go through them all one by one as into the stages. So the machine, we're going to use my UMC 750 to machine this. So I'm going to click on select. In my cloud, I've got my UMC 750. If you click on Fusion Library, there's a huge selection of pre-built machines from Fusion. They've got every HAS and all the main known models, and they're updated quite a lot. They keep adding to the list. So hopefully your machine's in there. If not, you're going to have to create it. So when I create a machine, I will select one that's roughly the same. The axis moving the same way, and then I edit that machine to be relative to my machine. Sometimes you have to create one from scratch, so we will go through that in another video. For this, we are using my 750. So I've selected my machine. Now, before you carry on with anything else, we've pulled the machine in. The third tab on the top, part position, we're just going to click on that, and then we're going to move the part relative to the machine table. So we've got a fixture box point, table attach point. It's already perfectly aligned, but on my device I have a point in the center bottom of that. I'll click that point, and then you'll click the center of the table, and it'll pull the part in. Right, let's go back to our setup. Operation type, we're milling. So you've got turning, mill turn, cutting for laser machines and additive 3D printers, etc. Our work coordinate system. Well, let's jump down to the model because it selected the whole model. So I'm going to select the model. And if we click on models, we can turn our stock off. We don't need the stock on. Model, we select the model that we're actually going to be cutting. Fixture, we select fixture, and then we can just select our component in the tree, which is our lang vise on the riser. Radial clearance, actual clearance, 2.5 mil. Sometimes I'll take that down to 0.5 mil or even 0, depending on what type of fixture or fixture plate I'm using. It's very important because you can leave this quite high. I think it's automatically set at 5 mil. But if you're cutting close, your toolpaths are adjusted as to not to gouge your part with the clearance setting here. So I've put in 2.5, and then I've clicked on the three dots on the side, save as user default. So mine's set at 2.5 mil. I very often cut close to the jaws. And this feature now is very nice because I have some very expensive jaws that are gouged prior to using this. So are we all done here? Yes. We can move to the next tab, stock. So we created our stock in the design workspace that I prefer to do just because it helps with the alignment of your fixture, and it's a lot easier and faster than using it in here. But you have it's the same options or similar options in here. But because we've made it already, we're just going to go from solid. So we're going to go from solid, and then we're going to click on our stock. So now our stock's perfectly set in our vise. Our part's set. Let's go back. We didn't do the datum of the part. Work coordinate system. So we've got model orientation. That's orientating the part as it is drawn in the workspace. That can be all over the place depending on who made the model. If I create a model, I try and create it exactly the same way that it's drawn. So this would be perfect, but a lot of models are all over the place. So just as good practice, you want to define your Z and X or your Z and Y axis. So if we select ZX, then we're just going to click on the face relative to the Z axis on the machine, and then a line for the X or Y axis, whichever one you've chosen. Our next one down, model point, this is actually going to be the datum point of the job. So I'm going to select this bore. The center of that bore will be my datum point on the machine. One key thing here, sometimes you're going to do a model and you're not going to have anywhere to reference the X and the Y axis from, but you might have, it could be a round part with holes around the outside edge that you need to hit, or there'd be features that you need, but you don't have an X and a Y axis. So what we would do is go back into the design workspace. I'm on the level of my machined component. Then I'm going to create a sketch. I'm going to select the top face, and then I can just draw a line. I'm going to make sure that it's a construction line. So if I come over to my sketch palette box, the first icon is construction. So any geometry that you draw under construction, Fusion is aware that it's just a construction line. So if I just go across 45 degrees from my datum point, I've now got a line in what I want to be my x-axis. So I can finish that sketch, jump back into manufacture, edit my setup, and my x-axis edge, I can then select my drawn point. So we've got our stock done, part positions done, post-process. So program number, change that to what we want it to be. Program comment, this will be your name at the top of the program. So let's just go riser operation 1. WCS, so this is changed from default because we've called our machine in. So let's go in without the machine on. Now we've got work offset. 1 will be G54, 2, 3, 4, 5, up to 6 for G59, and if you put 7 in, that would be G154P1, and so on. So let's pull our machine back in. On the machine, when I pull in my UMC 750, it asks me, so I've got extended, and then it would go 1, it gives you an example down the bottom, so 154P1. We just want standard, we're going to use G54. The last tab, what have we done there? Okay, the last tab, multiple work offsets. So if we had, maybe we was machining 2, or if you've got 6, there's a very simple way of duplicating the part, where we can click on multiple work offsets and then give it the number of instances. So if we had 2 side by side, we could say 2. Work coordinate system offset increment, so just by 1. So that means that if we're starting with 54, the next one would be 55. Maybe if you was hitting a part on 2 different faces, so on one single part you wanted G54, G55, and the next one would be G56, 57. For this operation, it would skip an offset for the next component, so you would want that to be 2. So then we'd have G54 for this setup, and G56 for the setup of the second component. Operation order by tool. So that will just ensure that when you do a tool change and that tool's out, it's going to be in that sequence, so it's going to hit the parts individually, minimizing tool changes. We don't need that right now. So that's our setup complete. If let's put it back in there. Riser operation 1, click OK. So now our setup is complete as to how it is on the machine. that's the end of this tutorial, and we move on to the next one.